Alright, everybody, we're back here for another fun day of Algebra 2. So today's topic is still continuing on our quadratic formula, but now introducing the concept of complex numbers. Alright, so what is a complex number? So basically, what is I? Alright, so I stands for an imaginary number. So here is our I term right here. I stands for the square root of -1. All right, which would then mean that I squared is -I. So I is our imaginary number. So it basically was invented as a way of being able to simplify a radical with a negative value. Okay, we're able to take the negative and move it somewhere else so that we can actually simplify the radical. Like in this example over here to the right. Here we have the example of the square root of -81. So we can break this up. So all radicals we can break up into the product of two radicals. So here is -1. Here is 81. So the square root of -1 we just learned today and right now in this video is I. Okay, so since these two things have been multiplied, these two things are going to be multiplied. So the square root of 81, well, that gives us 9. So our answer over here would be 9i. Okay, so it allows us to take the square root of 81 and still have this multiplied by this square root of -1, this I term. Okay, so it's still an imaginary solution, but it allows us to write it a little neater than what we'd normally just throw it off and say there's no solution to this problem, let's move on. Okay, mathematicians don't generally like that you can't solve something, so hence this number was created to help ease their suffering a little bit. All right, so let's now kind of use it with our quadratic formula. So in the quadratic formula, we've been doing that over the last couple of days. We have our 3x squared, our -6, and our 12. So we have our a term, our b term, and our c term. So our a term is 3. That is an a, by the way. Our b term is -6, and our c term is 12. So remembering our quadratic formula, let me just move my pad a little bit so it's easier to write, is negative, so I'll just write it up here, -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so putting that in here, so I have the opposite of b, so -6 is going to give me a +6 plus or minus square root of -6 squared minus 4 times 3 times 12 all over 2 times 3. Okay, so here we have 6 plus or minus the square root. So -6 squared is going to give us 36 minus 4 times 3 is 12 times 12 is 144 all over 2 times 3 is 6. All right, so 6 plus or minus square root, so 36 minus 144 would give us 108. Negative 108 over 6. All right, so normally, before we would say there are no real solutions, and there still are no real solutions, okay, because it's this key word of real, okay? There are no real solutions, but now we can actually figure out what our imaginary roots would be, okay? So if we have the square root of 108, so -108, so again, I'm going to take the -1 out, just do the square root of 108. So 108, we can see what goes, we want a perfect square that goes into 108 evenly. So let's try some in here. 108 divided by 2, divided by 2, gives me 27. Oh, all right, so it looks like 4 and 3 go in here. So 108 divided by 36 is 3. Great. All right. So it looks like 108, the biggest square root that goes into that, or perfect square that goes into that, is 36. Sorry, I had to check on the calculator a little bit. Square root, so 36 times 3 equals 108. So square root of 36 is 6. Square root of 3 is still square root of 3. And now with this 1, we have this I term. So now, so I just slide this back up here, we'd get 6 plus or minus 6I square root of 3. So we want to make sure we write the I, we can write a multiplication problem in any particular order, but we want to make sure we move that I to the front so that it allows us to know that this is outside the square root and it's not part of this square root of 3, because we don't want to get confused by that. All right, and now all of these have a 6, so I can just cancel out my 6's, and I'd get 1 plus or minus the square root of 3. And as you remember in class, this is known as a complex number. Okay, and complex numbers always have a pair. Okay, notice there are 2 solutions, and I'm sorry, there's an I right here. We did not cancel out that I. So 1 plus I square root 3, this is a complex number. Okay, complex numbers are always in the a plus or minus bi form. Okay, and there are always 2. So if there's a plus bi, there's going to be an a minus bi. So it's always a pair on our complex numbers, because when we take the square root of something, we are doing both positive and negative. We always have that plus minus because positive numbers squared and negative numbers squared equal a positive number. So we don't know which one of those works. More times than not, it's going to be the positive answer, but you do want to include both just to make sure. Okay. All right. So what happens in here? Where did my, oh, I'm sorry. Okay. The I clock. So there are ways to simplify our I. So here we have, so if we had the I of 0 power, that would be 1. Okay. I to the first power would be I. I squared, well, that's the square root of -1 squared. So as we saw on the other page, this equals -1. I to the third power gives us, well, that's the same as I squared times I to the first. So that would be -1 times I, which is -I. Right there. And then here we have I to the fourth. Well, I to the fourth is the same as I squared times I squared. So that would be -1 times -1, which would be +1. And what happens is, what the I clock kind of tells us, 1, 2, 3, 4, it now starts to repeat. Because if I have I to the fifth, that would be the same as I to the fourth times I. And I to the fourth I just figured out was 1. So 1 times I would just be I again. And we're starting back at square 1. So every multiple of 4 is going to be 1. Every other even number is going to be -1. So you can kind of follow this as we work. So we see a couple examples. So let's try a few that are down here. My pen to work. So here we have 27. So the key to kind of going through this is figure out, it's the I to the fourth that are the key. Okay, I to the fourth and the I squared, because those are actual numbers. Okay, so 27, well, 27 I can split up into I to the 24th and I to the third. Now I to the 24th, this is a multiple of 4. So every multiple of 4 is going to be 1. So since 24 can be evenly divided by 4, that's going to be 1. And then now I have the remainder, and I already know I to the third right here was -I. So 1 times -I is -I. Okay? Here I have I to the 45th. So again, first number, or go to the closest number that's a multiple of 4, In this case, that's 44 times I to the first makes 45. So I to the 44th, since it's a multiple of 4, is going to be 1 times I. So the answer here is I. All right. Here we have I to the 88th. Well, I to the 88th is a multiple of 4, because 88 divided by 4 gives me 22. So that's an even number. So this thing is just going to end up being 1. Okay, so the key to those, find a multiple of 4, work through it, and then the remainder, you have to follow your I clock. So this is kind of, these are the things you got to remember and kind of memorize for it to understand that I to the first is I squared is -1. Really, these two can get you everywhere else. And then it's just working with your exponent properties to figure out why these things make sense. Okay? All right, so let's try a few more examples. So here we have another quadratic, so we're going to go back to our formula. Okay, so here we have a is -2, b is -6, and c is -9. All right, so negative b, so that I get +6 plus or minus the square root of -6 squared minus 4 times -2 times -9 all over 2 times -2. Okay, so I get 6 plus or minus, so this would be 36 minus 8 times 9 is 72 all over -4. And I get 6 then plus or minus the square root of -36 all over -4. All right, so again, square root of -36, I break that into the square root of 36 times the square root of -1. -1 is I. Square root of 36 is 6. So this ends up being, I'm going to bring it all the way over here. We got 6 plus or minus 6I. We don't have anything actually under the square root in that problem over -4. So now we have a 6, a 4, and a 6. Well, they all can be divided by 2. So this will end up being 3, this will end up being 3, and this will end up being, and I'm going to move the negative to the top, so I'm going to divide everything by -2. So this will be -3, and this will end up being 2. So I have -3 plus or minus 3i all over 2. Now the reason we only have to put the negative here, yes, this would also have been a -3, but because we have this plus minus here, minus a negative is just going to be plus, and plus a negative is just another word for minus, so actually the plus minus just takes care of that sign anyway, so you don't really need to include the plus minus on the negative. It's just extra information that's not needed. So here are my two roots, and you would say that these are two imaginary roots. Okay, because again, with this plus minus, there's always a pair. There's never just one imaginary root. There's always two. Okay, all right, so let's kind of do some algebra with this. So you treat the I term the same as you would treat any other variable. Okay, so we saw how it kind of worked when we were plugging in the quadratic formula. Here, what if we gave it to you already in factored form? So if you already get it in factored form, then you can sit here and go -2 and all right. Sorry about that. Here we had, so we're gonna FOIL it just like we do any other variable. So here we have 2 times 3 is 6. Here we have 2 times 4i would be 8i. Here we have -2 and 3 makes -6i. And here we have -2 and 4i would make -8i squared. So just like a variable. Okay. And then we're going to combine our like terms just like a variable. So here we have an I term and an I term. So these could be added together, and I get 2i minus 8i squared. All right, so normally we would be done here because we have a 6, an I squared. However, I squared is -1, so this I can be replaced. And here's 2i, and here's 6. Okay, so moving this up at the top, I'd get 6 plus 2I plus 8. So now I have the 6 and the 8, and we get 14 plus 2I. So you will actually never, never, ever, ever get an answer that has an I to any other power other than 1. Okay, you should always just have one I term as you're moving through this. So it's something to keep in mind as we're going through. All right, and here 3 on the bottom. Again, do it the same way as with a variable. Distribute that negative. 9 minus 4 minus I plus 4I minus 5. Okay. And again, combine our like terms. So here we have 9, negative 4, negative 5. So that becomes 0. And here I have negative I and 4I, which is 3I. So 0 plus 3I equals just 3I. And there's our answer there. Okay. All right, so just a nice quick little video. So this will be part 1, and then I'll show you part 2 tomorrow. We can go through the conjugate. All right, see you guys in class.